Okay, we're back, and today we're going to be modeling a set of shelves with a cupboard on the bottom of it. I'm going to be using a technique called top-down design. Some of my other videos have some information about this because it is a technique that Fusion does really well, and it is also a way for you to make complex assemblies that can be easily modified without going all terribly wrong. So the very first thing I'm going to do is create a sketch on the front plane, and I'm going to make the height and the width of my set of shelves, and I'm going to put some information about like where my shelves are going to be and where that cupboard is going to be. It's important to me that I make these sketches very simple and only schematics. I don't want to have too much information in them because they are a source of major calculation for the software, so they will degrade your performance if they're overly complex, and they're a source of error for most engineers as well. You'll also notice I'm using the parametric functions of Fusion to create a relationship between that top shelf, its location, and it is going to be of the correct size so that I will always have 5 shelves equally spaced in that top section of my assembly. After that sketch is finished, it's very simple, but I can begin using that sketch to create other entities. So one of the first things I've done is I've gone into the parameters and I've given all those parameters that I created there names that are useful: height, width, and shelf locations, and the cupboard height, something like that. These are names that I can use later, and I won't have to remember the automatically created names of D1, D2, D3, and so on. It makes it much easier for me to use these later in the course of my design, and it is something I recommend. I also mark these as user specified parameters. They are starred. That means that they are especially important. Additionally, I created another user-defined parameter called material thickness because I do plan to manufacture this using material of a constant thickness, and by defining this in advance I can easily change that as I wish. Now the very next thing I did was to add another user-defined parameter because I forgot in the last step, called depth, and that is the depth of these shelves. That is 600 millimeters. I can change that anytime I want, and what I've done here is I go in and I create an extruded profile, and I selected those bottom 2 profiles for the cupboard, and I used that user-defined parameter of depth instead of putting in a number, and it works just fine. You can get it in a pull down. And I did the same thing for the top, and I again used the parameter of depth, which was previously defined, and it's really important here that I create a new body so that this new body does not join to the body that was previously created. And I have 2 separate entities, if you wish, in my assembly. Now you have to keep in mind that this is not truly an assembly. It is still one part with 2 different bodies. That is not the same thing as saying it's an assembly with 2 different parts, and more on that later. Using the shell command, I can click on surfaces and tell the software I would like to remove those surfaces, and everything that's left should be hollowed out. This is commonly used for plastic design parts, but you can use it here too. And I can make use of my user-defined parameter material thickness to give these cabinet cases a constant wall thickness corresponding to the material that I'll use later. So you get something that looks like this. It's quite nice. Now looking at it, I saw that the top was sitting directly over the cupboard, and I didn't like that. So I pushed my timeline back down at the bottom, and that means I go back to the time before the shell took place. And before the shelling happens, I use the command push-pull to just push the sides in, I believe by minus 25 millimeters, and then the back, I believe by 35, and I believe the front by 40, something like this, to just change that overall shape. And since it's a separate body, that works just fine. And once I'm done, I can just roll the timeline forward, and that shell now happens after those pushes. So you'll get a result that looks like this, and that's exactly what I wanted. So we've got a finished shelf, and we can move on to the next steps of detailing it out.